Toon.
Well, hello, everybody. You probably think of connections and communication as being quite straightforward, quite simple. But actually, it can be quite complicated. So let me try and give you an example. From my house, I can see a tree, an oak tree. I can see this tree because light photons have traveled 150 million kilometers from the sun and interacted with this tree. Some of them have bounced off and have hit the photoreceptors in my eyes. These receiving neurons connect to the neurons in my brain, and they help me to understand information about this tree, about its color, about its shape, its position. All of this is happening as a result of connections that are going on. So these connections are very, very complicated. Now, when you communicate with a friend, for example, you use language. Language is actually a form of encoding that you use to transfer information. And what's interesting is that other species use language too, different forms of encoding. For example, bats use very high frequency sounds to communicate with each other. They actually have a very rich language. They even have unique call signs for each other. They have names. Hello, Fred, they're saying to each other. And whales similarly use different forms of encoding to communicate with each other. They have a very rich language. But you, when you're talking to your friend, they probably speak the same language as you, and you're able to easily transfer information between each other to build knowledge. Now, if the environment is noisy, maybe you can't talk, maybe it's too loud, maybe the connection is broken. But what you could do is use a different form of encoding. You could write your message down, pass a note, send a letter if you're very old-fashioned, or send an email to transfer information using this different encoding scheme over a different type of connection. Connections in all these myriad forms allow us to transfer information. Now, I had a slight challenge when I was young because I struggled with reading. I struggled with one of these forms of encoding. I have a mild form of dyslexia that makes it difficult for me to necessarily see words in the same way that other people do. What happens in dyslexic is different parts of the brains that you would normally use for reading, actually the connections in those parts of my brain don't quite work the same, then the connections are not as good. And what you do, or what I was able to do, was to subtly reconnect and use different parts of my brain, the spatial parts of my brain, to understand and to be able to start to read. It took a little bit of time, but ultimately I was able to do that. But this neural diversity, and we are all neurally diverse, we all have different ways in which our brains operate. In my case, I was very good at numbers. I can see a page full of numbers, and I will show you the number that's wrong in that setup. And I started to become interested in computers. And I found that clever computers also can't read, and they can't write. And they're not even very good at numbers. They use a very simple form of number called a binary digit, or a bit, which was developed or proposed by this incredible mathematician and engineer called Claude Shannon back in 1948. Now, Claude Shannon is a really important person. He is the father of our information age. Without him, we wouldn't have the internet. We wouldn't have Wi-Fi. We wouldn't have mobile phones. He recognized that information can be described using this very simple bit, a single 1 or a 0, like a switch that's on or off. And all information can be described and built up using these bits. Maybe that's not so surprising today when all of your books and your music are stored as bits, or maybe even on the internet. But it was Claude Shannon who came up with these ideas. And what he described was the way that a receiver has to receive information from a transmitter. And what you're trying to do is, over that connection, ensure that those two people or two entities are able to see the same information. We're trying to remove the uncertainty, the relative information between the receiver and the transmitter. We're trying to get them to be the same and get rid of all that uncertainty. Now, you've maybe played the parlor game Chinese Whispers, where you've passed a simple message to one person who passes it on to the next, who passes it on to the next. Very quickly, that all gets garbled and you don't quite know what the original message was. Things get lost along the way because the communication is imprecise. We're losing information. You've probably been in an argument at some point, maybe with your partner or a friend. And what you've discovered is that just shouting louder and louder really doesn't work for you. What you need to be able to do is to start to listen, to actually hear what the other person's saying, and you need to try and come to some common understanding about the issues, or the argument will never be resolved. And the interesting thing here is that these connections happen everywhere. Your cells inside your body are communicating. The DNA in your cell is telling it what purpose it should have, part of your skin, part of your liver, part of a neuron in your brain. And it's communicating with the other cells to create the whole person that operates together as a single person. All of that communication happening inside of you. Plants do exactly the same thing. Their cells all communicate with each other as well. And these plants are actually incredibly intelligent machines. They will point their head towards the sun and track the sun as it moves. They'll emit a scent to attract bees to come and collect their pollen and take it to the other flowers so that they can communicate and pass information to breed and to create new flowers, driving evolution. Evolution itself is a form of communication where you're passing information down to the species, to your children. Now, I don't want to pick on anybody in particular here, but you all share nearly 50% of your DNA with a cabbage. Now, don't read too much into that. You have a lot of other DNA as well. But we are all connected to all the other natural objects on our planet. About 3.5 billion years ago, a cell divided and started to split and created all of the diverse forms of life on our planet. We're all connected. We're all cousins, maybe quite remote, but you are related to a cabbage. Now, connections also allow us to build knowledge. Our brain is full of connections. Most of your brain is actually the connections inside, the connectome that connects all your different neurons. And the neurons, when they're sending information, they use a little electrical spike over these synapses that create these connections. Your brain has been optimized to connect neurons that communicate often, putting them close together. It optimizes the speed so that the information can be reliably sent. It makes sure that there's not noise to ensure that the information can be turned into knowledge inside your brain. So evolution has helped us to develop this way in which we are able to learn. And the amazing thing is, the brain follows exactly the laws that Claude Shannon described that actually power our internet, power our Wi-Fi, on all of our information age as well. Now, insects have exactly the same kind of connections. Their brains are much smaller. Their brains are much more efficient from an energy point of view. They are optimized for that particular species. We make the trade-off of having much larger brains that we use to find more food, to get more energy, but also allows us to build tools and amazing things like AI. Now, AI is this new technology that we've developed. It also uses connections to build intelligence. You are taking information and turning information into knowledge, and from knowledge, you are creating intelligence. Now, how AI thinks is the way in which you connect these artificial neurons together to be able to create a method where the AI can be trained to learn from information. This is something that we're doing. It's not doing it on its own. Humans have designed how these AIs should be connected and are allowing it to then learn from information. For example, to build this incredible image, which is generated by AI. But AI is also learning to write and to read. Things like ChatGPT are using very large models to be able to start to understand the structure of language and use that to create new language and new outputs in incredible detail. The outputs are phenomenal. They're using artificial neurons connected by what we call parameters. Parameters are the connections between the artificial neurons, and it's these connections which is actually where all the incredible power is. GPT-4 that powers ChatGPT today has about 1.7 trillion parameters. Your brain has about 100 trillion parameters, so still much, much bigger, much, much more capable. And these are a little bit inefficient compared to the amazing efficiency in your brain. Now, AI deep neural networks are driven by these connections. It's the way in which we describe these connections which are what allows it to capture knowledge from information. So connections are really the power behind artificial neural networks and behind AI. So, returning to the start, we get light from the sun. We get energy from the sun that allows us to all live as species here on this earth. It's the energy that allows us to survive. The light lets us learn about our environment so we can understand our environment and survive as species. And as I learn more and more about this incredible environment that we live in, I'm struck by how much connections are involved in this whole makeup, how we're all very much connected together. And so I think we all need to get much more connected, and I believe AI can help us. It's already helping us to understand more about DNA, about cells, about language, and about the way that animals' language works as well, so we can connect with the other species on our planet that we are all connected to. So we all need to learn much, much more about connections, and hopefully you'll go away today thinking that that is something that you want to do, to see how you're connected and how we're all connected. Thank you very much.